All right, welcome. So today we are talking about simple differentiation. In class before we talked about the derivative of the function. Well, differentiation literally just means the process of taking the derivative, also known as the gradient function, because like we saw, the derivative of a function gives you the slope of that function at any point. So there's a couple of ways we can denote the gradient function. If they give you f of x, then the slope of f of x is written as f prime of x. If we're given y, we can either write it as y prime, or we can write it as dy over dx, or simply called dy dx. If you notice, that actually looks just like the slope formula, right? Only instead of writing delta y, we are writing d. So in calculus, if you study this, it'll have slightly different connotation than just putting the deltas, but for our purpose, we can just assume that they're kind of the same thing. So hopefully when you were working out the formulas, you noticed the pattern. The slope of a function where it's x raised to a power is always the power multiplied to the original function and then divided by x so that the power drops by 1. We know from Algebra 1 that if I have the slope of a horizontal line, so such as like a y equals 2 or y equals 3, that slope is 0. So if you have a constant, the slope just becomes 0. And then finally, if you have several terms being added together, hopefully you notice that we can just sort of take the derivative of each thing and add it up. All right, so let's see this in practice. So we have two functions, 2x cubed and x squared plus x. And if we want to take the derivative of each function, we're just going to apply the rule. So I'm going to take the exponent, multiply it out, so the 2 becomes a 6. And then I'm going to divide x cubed by x, and it drops to x squared. That's it. So f prime x equals 6x squared. So over here, right, if there's not a number in front of the x, we treat it as a 1. So 2 times 1 gives me 2. The x squared loses an exponent, so it drops to 1. Of course, if I have a 1 as the exponent, I don't have to write it. The slope of y equals x is simply 1. So there we go, 2x plus 1. Another way to think of the x by itself, if I don't write an exponent, then it's implied that it's 1. 1 times 1 gives me 1. And then if I drop the x from x to the first power, it becomes x to the 0 power, which means it goes away, which means just the x by itself would turn into a 1. All right, I will let you do 2 on your own. So first, use your rule we just talked about to find f prime, and then take these guys and plug in to the formula. Our next example, we need to find the gradient of the function or of the tangent to the function at a specific point. Right? So this is what we were doing in class. Only now we have the shortcut. So if I'm starting with y equals x squared, the gradient function for y equals x squared is 2x, right? Because the 2 multiplies to the front, and then we drop an exponent. And if I know that x equals 2, then the slope is equal to 2 times 2, which is 4. So the next one's the same thing, it's just the formula is a little bit more complicated, right? So again, our gradient function, 2x squared is going to become 4x. The slope of negative 3x is just negative 3. And we know that the slope of a constant value is 0, so the 7 just goes away. tells me that x equals -1. So we plug in and reduce. All right, so for example 3, I will work number 10 and leave number 11 for you. What point on the graph of y equals x squared minus 4x plus 7 does the tangent have a gradient of 2? So, notice, this is the same thing we were just doing, only we got to work it slightly backwards, right? We know if we want to find the slope, we take the derivative. So x squared becomes 2x, 4x becomes 4, 7 goes away, and I want to know what value of x I need in order for this to have a value of 2. So that means we set up the equation 2x minus 4 equals 2, and we solve. There we go. I will let you try number 11 on your own. Let's look at our last example. So we want to find the tangent, we know that the tangent to f of x when x equals 1 has a gradient of 10, and we need to find a. What are we going to do first? How about we start by getting the gradient function. So f prime of x is 3x squared plus a. So remember, in this case, a is sort of a constant on its own. Right? So the slope of the 5 is 0, so that's just going to go away. We know that x equals 1, so we can plug it in. So 3 times 1 squared plus a is just 3 plus a. And I know that in order to find a, the gradient has to come out to 10. 3 plus a equals 10, which tells us a equals 7. All right, there's a couple more problems for you to work. I'll leave those to you. That's all we have for today. I will see you next time.